This is Geometry, Unit 3, Quiz Number 1 review. We've talked about properties of algebra and of geometry. This is the reflexive property of equality. So the measure of angle C is equal to the measure of angle C. Reflexive property is like a mirror and it reflects back and forth. Transitive property of equality, AB equals XY, XY equals PQ, so AB is going to be equal to PQ. So notice that when it refers to property of equality, they're using equal signs. Substitution property of equality. We know that x equals 4, and we also know that x plus y equals -8. So we're going to substitute the 4 in place of the x. So this is 4 plus y that equals -8. Transitive property. This is of congruence. Notice that we have congruent symbols. If angle 1 is congruent to angle 4 and angle 4 is congruent to angle 6, then angle 1 should be congruent to angle 6. The transitive property requires 3 pieces of information. The first 2 set up our third one, the hypothesis and the conclusion. Reflexive property of congruence. Notice it uses congruence, so that tells us we're using a congruent symbol. When you talk about angles, you don't use the M before it. You don't use the measure of angle K, because it's not about measure, it's about the size and shape. So we say that angle K is congruent to angle K. Here we have the 3 parts I referred to, and we notice that it's congruence. So it's transitive property of congruence, and you can abbreviate that POC. Here we see that KS is equal to KS, so that's reflexive because it's equal on both sides, or the same on both sides, and because it's an equal sign, it's property of equality. POE. The measure of angle B equals the measure of angle C, and the measure of angle C equals the measure of angle P. Then the measure of angle B is equal to the measure of angle P. What property is using that? It has all 3 parts. Again, that's the transitive property. Transitive property of, these are equal signs. All the angles have an M in front. So it's equality. Here we have reflexive property of congruence. Congruence, here I almost wrote a E. It's congruent, so it has to be a C because it's of congruence. That's a congruent symbol. This is kind of a tricky one. Notice that this portion, where we have 3a plus 1 minus a, is going to turn into 2a plus 1. So in other words, these a's came together. They're on the same side of the equal sign. Here we have -3 plus 4a plus 6. Then we have 4a plus 3. So here, these constants came together. Here we are collecting like terms. The a's got collected, so 3a's minus an a gives us 2a, and -3 plus 6 gives us a positive 3. We did not add the same thing to both sides of an equal sign, so there is no adding or subtracting to both sides. It's just collecting what we have here together and collecting what we have on the other side together. Write a conditional statement in if-then form. 2 segments that have the same measure are congruent. If 2 segments have the same measure, then they are congruent. You can use a congruent symbol. So if then, the hypothesis is the segments being congruent, and your conclusion is they are congruent. Two segments having the same measure, then they are congruent. This is kind of a weird thing. All living things are green. If it is living, then it is green. Living means that it's green. And we can probably think of a lot of different things that are living that are not green. But they're not asking us to do true and false. Here, we're going to talk about how this conjecture, how this conditional statement, assuming that it's false, then we're going to give a counterexample. The average of two consecutive numbers, two consecutive even numbers, is an even number. That's their statement, that we're going to get an even number when we take two consecutive even numbers, take their average. So consecutive numbers would be like 1 and 2. Consecutive even numbers would be like 2 and 4. So if we take 2 plus 4, take the average of them, that means add them together and divide by 2, we get an odd answer. So 2 and 4 would be an example of two consecutive even numbers that are not an even value when you take their average. Any four-sided shape is a square. So the question is, can you draw a four-sided shape that is not a square? Well, there's several of them. A very popular one would be a rectangle. It has some properties like a square, but it's not a square. If the products of two numbers is positive, then the two numbers being multiplied are both positive. So if we think of 2 times 3, those are two numbers that are positive. Do they create a positive? That's not really what they're asking. If the products of two numbers are positive, here we got positive. How do I get a positive answer? If the product of two numbers is positive, then the two numbers being multiplied are positive. Do they have to be both positive? Well, we know like 5 and negative 7 would be negative 35. So that's how you get a negative answer. But what if we do negative 4 and negative 8? Their product is a positive answer. So then the two numbers are both positive. I can get a positive product if the two numbers are both negative. So that would be my counterexample. Given the statement, write the converse. So this says, if the measure of an angle is 120, then it is obtuse. We could consider that a true statement. If an angle is obtuse, then its measure is 120. And that is going to be false. It doesn't have to be 120. Is there a different angle? Is there a different conclusion given this hypothesis? Give me an obtuse angle that is not 120 degrees. That'd be like 150 degrees, 100 degrees, 95 degrees. Anything greater than 90, less than 180, would be considered obtuse. Now let's look at this original one. If the measure is 120 degrees, then it is obtuse. Could we consider this to be something different than obtuse? It's not a right angle. It's not an acute angle. It's not a straight angle. No, it has to be obtuse. If 4 points are collinear, then they are coplanar. If we have 4 points, no matter how we lay those 4 points on the same line, collinear, all points on the same line, then we can consider those to all be on the same plane. But if 4 points are coplanar, then they are collinear. And can I make 4 points coplanar but not put them on the same line? Of course you can. So that would be your counterexample. Here's an algebra proof. So we're just going to do algebra. There's not much planning. It's just doing each step by step. 3x plus 8 equals negative 2, 2x plus 7. So that first step is considered given. Now let's see what we can do. This looks like the distributive property. When working with algebra problems, we don't do a lot of planning. You just kind of do what's ever available when you're there. And we don't consider it distributive property of equality because the distributive is not happening to both sides of the equal sign. Here we're adding the 4x over. So if you want to do the math in the problem, that will help you see it. 7x plus 8 equals negative 34. That was addition, clearly added. Addition, property of equality. Here we're minusing 8. So 7x equals 40 actually, 42. And that we subtracted the 8 across, so that was subtraction. Property of equality. What's our last move going to be? What are we going to need to do? Don't just sit and copy me. You got to make these decisions on your own. Always pause the video and see if you can work through the problem without me. That's the key way to do it. Here we'll divide by 7. That's a division property of equality, and we get the answer of 6. 6 times 7 is 42, so 42 divided by 7 is 6. Last ones. The city is planning to add 2 stations between the beginning and the end of the community train line. Using this information, using the information given to determine whether RS is going to be the same length as TU. Really, the only thing that we know is that RT is the same length as SU. So RT is equal to SU. So we're making our plan first. Before you start your proof, before you start putting pieces in like a puzzle and you're just trying to see how they might fit, try to plan it out. Try to see what actually works and why this is happening. Why is RT, the pink, equal to SU? That's not why, that's just the given information. Why is RS equal to TU? Well, if the pink is equal to the blue, and now you see this is blending together to be a little bit like purple. So if I get rid of the purple, the equal amount out of both of them, I'm going to be left with two portions that are the same. So I made a plan. I have to get rid of the portion that's the same, and I'm going to be left with two pieces that are also equal. RT is equal to SU. That was our given. We see that RT is equal to RS plus ST. That is the segment addition postulate. Now they're talking about another segment addition postulate. Well, this segment addition postulate was about the pink. So maybe it helps us to say that it was with the pink. And SU is made up of ST plus TU. That looks like this one. We've already used one of the segment addition postulates. So we have a pink portion and we have the blue portion. Now we're supposed to do something with substitution. So we're looking for something that used to be equal, but now we know what their parts are. So if RT is actually RS plus ST, so we're going to put this portion there, and SU is actually this portion. If the two segments are equal to each other, then their parts are equal. The sum of the parts are equal. That would be substitution. We're taking the RS plus ST and plugging them in here, because that's what RT is. And we're taking the ST plus TU and plugging it in for SU. So plugged in for SU. Plugged in for RT. And then we subtract ST from both sides of the equation. That gets rid of them both, and we're left with RS and TU. Subtraction, property of equality. And we used this one up in the given, and that one was here. So we used all the possible boxes. Kind of like a multiple choice option. But notice I didn't try to make a puzzle out of it and see where it fit best. I tried to decide where it was, and then I looked to see if it was one of my boxes. All right, last one. You got to make a plan first. I notice that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is making this straight line. I know that angle 1 is 32 degrees. I know that angle 3 is the same as 1. We need to be able to show that angle 2 is 116 degrees. So if I want to figure out that this is 116 degrees, I need to take the 180 and get rid of this 64. That would give me 116. So that's my plan. Know that I have 180, and then subtract what I know to see what I have left. So here is our given information. Now this one's a little interesting because they apparently have split the given up. I'm not putting the whole given all at once. This is enough information from the given for me to talk more about. So let's first talk about what's true if this is the first thing we know. Measure of angle 1 equals the measure of angle 3. Well, regardless of that, I know that 1 plus 2 plus 3 adds up to be 180 degrees. Because it equals 180 degrees, I don't think this is the best notation though. But this a small part, a small part, a small part equals the big part. Typically we say it's not with any numbers like degree values. But here they're using that. I don't like it so much, but they're trying to represent the angle addition postulate. Now we know that 1 is the same thing as 3, or 3 is the same thing as 1. It really wouldn't matter which way we go, but 1 is the same thing as 3. So we're going to take the 3 out of here, and we're going to put the 1 in its spot. That was substitution. Property of equality. And then I notice I have 2 1s together. So we're grouping those 1s together. When we're grouping those together, we call that combine or collect. Combine like terms. Now the other piece of given, a given that I haven't used yet. I've taken this 1 and 3 all the way as far as I can. There's nothing else I could talk about. So now since we know 1 is actually 32 degrees, that's the other part of the given, I can put the 32 degrees in place of the measure of angle 1. That's considered substitution. Now it looks like they've grouped that together. So that would not be multiplication property of equality. That would be more we're multiplying it in as a distributive property. We've already used that one. We've already used that one. I guess we already used angle addition postulate, but remember, we're not thinking about this as a puzzle. Okay, how do we get to 116? Well, we minus the 64. So that is subtraction, property of equality. Good luck, everybody.